In this section, we look at factoring trinomials of the form ax squared plus bx plus c. It doesn't sound like a big difference from what we talked about before, but that a number other than 1 in front of the x squared, is really going to increase the difficulty of factoring. The first thing we're going to do is look at a process I just refer to as trial and error. We're going to look at two binomials multiplied together and see if we can come up with the FOIL process that produces this trinomial. So I know I want the answer to look something like this. In fact, I know I want both pluses since there are no negatives in the trinomial. The first thing I want to think about is how is 2x squared going to be produced? 2x squared is going to come from the first terms in FOIL. And luckily for us, the only way to get 2x squared is 2x times x. So this is like a given in this problem. Now the other one isn't going to be quite as easy. The number at the end, the 3, is the last part of FOIL. That's when you multiply these two numbers together. It seems pretty simple because there's only two factors that produce 3, but I'm not sure what order they go in. And it actually makes a difference here. It's either going to be 1 and 3 or 3 and 1. And really, we don't know ahead of time until you try it. So let's go ahead and take a look. Let's try 3 and 1. The way you check is to go through the FOIL process. I'm going to multiply through. I'll get 2x squared plus 2x plus 3x plus 3. Now, just as we intended, that first term is 2x squared, and the last term is 3. It's the middle that we have to concern ourselves with, and this just doesn't work. 2x plus 3x is not the 7x that we were looking for. So basically, I had a 50-50 chance, and I guessed wrong. So I'm going to start over, and I'm going to switch the order. I'm going to put the 1 first, and then the 3 next. Let's try this again. When you FOIL this time, once again, FOIL produces 2x squared. I knew that was going to happen. But then here's the important stuff. 6x plus 1x plus 3. This is exactly what I want. The 6x and the 1x give me the 7x in the middle. That must be the answer. So the answer to our problem is 2x plus 1 times x plus 3. Just a little bit of trial and error will produce it. Now, trial and error works great for numbers that are small, like in this case we had 2 and 3, and also prime numbers that don't have that many factors. Look at the next one, though. Think of all the possibilities that there could be. Let's just think of a few. For example, just to get the 6, we have a couple different options. I could do 2x and 3x. Or I could do 6x and 1x. Okay, not too bad, just two different. But then here's where it gets worse, negative 30. Negative 30 has a lot of factors, and we're going to have to account for all different orders. So negative 30 and 1 could be swapped positions in these. This has got to be at least 20 different scenarios you could get. A lot of work. Now, hopefully, you'd get lucky in the very beginning, maybe on your first or second try. But there's always that chance that it could take all 20 of those choices to get there. So we need a new method, something that's not going to take this long. So if you have something other than really low numbers with like prime numbers, let's use a different technique than trial and error. So we'll skip over this problem and look at a new technique that won't require as much. Okay, so here's the first problem I want to look at. 3x squared plus 14x plus 8. In this new technique, we're going to concentrate on a magical number here, the 3 times the 8. That's 24 for this problem. Okay, so 3 times the 8, first times the second. We need to make a list of all the factors because what I'm trying to do is come up with factors of 24 that add up to be 14. So let's think of some of those. We have 24 and 1, 12 and 2, 3 and 8, 6 and 4. I'm going to choose the 12 and 2. The next thing we're going to do is write this trinomial in a very special way. Instead of writing that 14x in the middle, I'm going to write it as a sum of this 12 and 2, like this. So I haven't changed the problem at all, just written it in a very, very special way. It's still 3x squared plus 14x plus 8. This sets up factoring by grouping that we had discussed earlier. None of the terms have anything in common, but some of them do, specifically the first two and the last two. Let's look and see what they do have in common. 3x squared and 12x have a 3x in common. Two x and 8 have a 2 in common. Now, do you see what happens? Each one of these terms now has something in common. It's an x plus 4. I can factor that out and write what's left over beside the 3x from the first term, the 2 from the second term. That's the complete factorization. Always guaranteed in 3 steps. Let's try another one. In this one, this magic number that we're looking for is 48. It's the 16 times 3. Okay, so let's think about all the different factors that we could use, like 48 and 1, 8 and 6, 4 and 12, 24 and 2. What I'm trying to look for is what are the two numbers that when you add them together, you get the 26, actually negative 26 in the middle. That would be 24 and 2. The only thing I'm going to have to change is I'm going to make both of them negative. That way we'll get negative 26 there. So we'll rewrite the problem. Instead of negative 26 in the middle, I'm going to do minus 24x minus 2x. Just like the previous problem, nothing is in common to all of them. But there is something in common to the groups. In the first one, there's an 8x in common. Now in the second one, there's nothing really in common other than I don't like that minus sign there. So I think what I'm going to do is factor out a negative 1. That would make it positive 2x minus 3. And now maybe you see why I did that. There's two common factors. There's a common factor of 2x minus 3 here. Left over, an 8x minus 1. This is the complete factorization. I want you to try this next one yourself, just to make sure you're following along okay. So for this one, just to get you going, we need 6 times negative 6, or negative 36 is that target number you're looking for. Make a list of all the factors, including positives and negatives, and then see if you can rewrite the trinomial. So pause the video, and then as soon as you think you have it, go ahead and restart. All right, let's see some numbers you might have used, like negative 36 and 1, 36 and negative 1, 9 and negative 4, negative 9 and positive 4, 12 and negative 3, negative 12 and positive 3. I think I have them all. Let's look for the one that adds up to negative 5. Right here it is. So when you rewrite this trinomial, it's 6x squared minus 9x plus 4x minus 6. So instead of writing negative 5, we're writing it as negative 9 and 4. Now, a lot of students have questions, does it matter the order you put them? And the answer is no. Your work may look different, but your final answer will be the same if you put the 4 first and the negative 9 next. Okay, we have some groups of numbers now. There's a common factor of 3x in the first two numbers, and a common factor of 2 in the next two numbers. There it is, happened once again. Another common factor of 2x minus 3. I'll write what's left over in parentheses. There it is. The complete factorization for this trinomial, without guessing. The next thing we're going to do is just take it one step further, and that is solving equations. So you'll create these binomials so that we can solve them. They're kind of long problems. Let's look in this one. The numbers that I want to go for are 3 and 10, so 30 is my target number. Luckily, everything's positive, so that makes it a lot easier for us. We'll have 10 and 3, 15 and 2, 30 and 1, 6 and 5. I'm choosing the choice that gives me 17 when you add them. Right there it is. This trinomial, I'm going to write as 13x squared plus 15x plus 2x plus 10. Now keep in mind, off to the side here, let's write an equals 0, because that's what we're going to have to do in the very end. All right, grouping these together. The first two have a 3x in common. The second two have a 2 in common. And once again, remember, this is an equals 0 problem. Between these two factors, there's an x plus 5 in common and a 3x plus 2 left over. Now this looks something like what we've done before. It's the zero product property allows you to say either the x plus 5 equals 0 or the 3x plus 2 equals 0. So we have two solutions, negative 5, and after solving this one, negative 2/3. Let's look at one last example together. For this one, when you multiply the numbers together, 24 and negative 15, you might notice already things are starting to look a little tough. 24 times negative 15 is negative 360. Negative 360 is a highly composite number, and basically what that means is there are a lot of numbers that divide into 360. In fact, there are 24 different divisors, meaning 12 different factor pairs. Now that's not even including the whole negative, the negative 360. That would double by switching the negative. So we actually have 24 different combinations. I wanted to show you this example because sometimes in web design, the numbers get very, very large, and it just seems unreasonable. For your test, all the numbers will be, in my view, reasonable values for you to come up with the factors. This one's getting to be a little too much. Now, we'll do it as an example because if you do come up with a problem like this in WebAssign, I want you to be able to find the solution. I think the best way to do it, even in Google, you can type in factors of a number and it'll list all the different factors for you. So you can start to narrow it down. I mean, write down the ones that you know just off the top of your head, and then you can fill in any extras if you're still looking for a value. You can also use some strategies to eliminate some possibilities. For example, I mean, in this particular problem, I'm looking for the number 2 when I add them. So, one of the first ones I normally do is 1 and the number. There's no way this is going to be close to the number 2. So you can kind of get away from something like that. It's just too big. But I know we do have a lot more factors, like 2 and 180. And again, you have to account for negative 2 and 180. mean, the list goes on and on. What we want to do is try to come up with numbers that are factors that are generally close to each other so that when you add, or in this case, add and subtract the other one, you get the number 2. I came up with 20 and negative 2, or 20 and negative 18. So these are 2 factors. When you multiply 20 times negative 18, you do actually get negative 360. But like I said, in total, there's 24 of these. That's a lot. So don't get frustrated. Use whatever resources you can to complete the homework assignment to come up with the factors. And if you still can't figure it out, let me know and I'll certainly move you along on those. Just to clarify, all of the problems on test will be reasonable and never this large. Okay, let's go ahead and finish this one now that we know what the factors are going to be. 24x squared, I'm going to use 20 and minus 18. And again, this is solving an equation, so there's an equals 0 over there. When you group them together, we have a common factor of 4x and for this part, we have a common factor of negative 3. And just as we had predicted, there's going to be some common factors here. There's a common factor of 6x plus 5. So I'll take that out and write what's left over next to it, which is 4x minus 3. All right, set each one equal to 0. Either 6x plus 5 equals 0, or 4x minus 3 equals 0. By solving each one of these little equations, we find that the answers are negative 5/6 and 3/4.